Okay, so we have that. Now, keep in mind, this is the big deal. If you've tried those problems and you got really stumped, okay, that's about normal. Okay, that's why I'm spending like a whole week just on this one section. Because there's only an infinite number of optimization problems out there. And so the only thing that I can try to teach you is how to solve the problem. That's it. I'm not going to teach you how specifically to do any problem than just these examples. You have to just learn from me how to approach a problem. And if you try a problem and you can't get it, okay, scrap it and come back to it. Move on to the next one. Give that one a shot. See if you can come back to it. This assignment's going to take a lot of space, a lot of pages, but and so give yourself that space and the time to be able to do it. The last thing that you should do is give up. Okay? Don't give up on these, because it's a critical thing that you have to know how to do on the AP exam. Plus, it's a critical part of calculus. This is a big deal. So let's take a look at this one here. What I have here in front of you is a soda can, and it says a soda can contains 12 fluid ounces or 355 milliliters. Directions are: find the dimensions of the can that would use the least amount of material. Okay, ignore any irregularities of the can. You know how they make the can, they're all different on the top and the bottom and all that. Okay, we're going to use a pure cylinder for the problem. So the question is, you're being hired as an engineer for Pepsi, okay? And you have to determine, picture this, how many cans do you suppose Pepsi makes in a day, in a week, in a month, in a year? It uses quite a bit of aluminum, wouldn't you think? So if they made a poor choice in the design of the can, they would actually use more aluminum than what they should. And you know, every one of those cans means we're kind of throwing away money, or we're using up more materials than what we should. Okay? So lots of different choices there. So here's the deal. They could say this. I want to make sure that we're all on the same page. Here's the standard can, okay, relative to size. That's the standard can, okay? Grab that, drink that. But there could be a guy who says, I've got a new idea. Here's the new can. The new can is going to be like old pixie stick. You know those pixie stick things they used to cut off the top and...
Oh.
Remember that? Not the little ones, the big ones, the big gigantic ones. You can make your thing get all sour if you pucker up like that. Couldn't they make a can like that? And you got an opening up at the top, and you're walking around your can. Okay, you know, I'm gonna go take a drink. You know, you kind of do like this, right? That's doable, right? You could put 355 milliliters or 12 ounces. Every one of these contains 12 ounces or 355 milliliters. That's what we call the restriction. They all have to contain this much. Okay? Which one do you think uses more aluminum? This one probably does. Okay? Well, another guy could come around and say, oh, I got a better idea. We're going to make the pancake. Okay? Here's the pancake can. Can you picture this? Mm-hmm. And then there's like a little, the opening is on the side here. And so when you drink out of this, you know, I guess it's kind of like a flask, like a canteen. Yeah. So here it is. You know, it's like this. So you can screw off the top maybe, and then you can drink it like this. You follow? Okay. So we got the canteen, we got the pixie stick, and we got the normal one. Okay. How many different combinations can we have of cans? Infinite number, right? Because these are all cylinders, okay? And that's the point. We're going to use only a cylinder shape. So the question is, which one of these gives you the least amount of aluminum, or forces you to use the least amount of aluminum? That's the question. question that we're trying to solve. Okay, so for 355 milliliters, there is an exact answer, and we can figure that out. And that's what we're gonna do. All right, we go to the problem-solving steps. What was the first step of all the problems? Read and understand it. Do we understand the problem?
Mm-hmm.
Okay. All right, what's step 2?
What you know.
Identify what you know. Okay, so we're gonna make ourselves a list. Lay it out on the table. What do we know?
12 oxygen equals.
Yeah. In fact, for this problem, we're gonna use 355 milliliters. Okay, we're gonna use milliliters because of the conversion. What's the conversion that we can use? 1 milliliter equals 1 centimeter cubed, okay, 1 cubic centimeters. This is the most brilliant thing that anybody ever came up with. And why we as the United States don't use it is beyond me. Because everything would be so much better if we used the metric system, okay? Because here we have an automatic conversion between volume and then our lengths of our figures. We still have it, but here it's just beautiful. Yes.
On that, how would you do land then? You'd have like convert acres to meters, square
Yeah.
or whatever? That
We
be
would measure everything
So
in
you're doing like
kilometers.
257.386.
What do we do now?
357.836.
Yeah, so we would have measured it in something similar. But see, it's just, it's good. All right, what else do we know? Or what else would be important in this problem? Need everybody really thinking on this. Sure, volume of a cylinder sounds like an important thing. What is the volume of a cylinder? You won't be asked this on the AP test. You will be given it, but
4/3 pi r cubed.
close. That's for a sphere.
Oh.
That's a,
Squared times bigger.
what do you think is important for the volume of the cylinder?
Height.
Height
Radius.
and the radius. Those are the only two things that we need, actually. Okay? This is what's called a right circular cylinder because this is a right angle from the height to the base. Okay? You can have slanted ones, but that's not what we're talking about here. So this is the radius and that's the height. It turns out, and we're going to explore this more in the second semester with shapes, the volume of a circular cylinder is the area of the base times the height. Area of the base times the height. All right, what's the area of the base? Just pi r squared. You will have to know that on the AP test, area of a circle. And then the height. So it's pi r squared, h is the volume of the cylinder. Okay, what else do we think we should know? Think about what we're trying to find. What are we trying to find? Dimensions. Okay. How much aluminum? Surface area. So now we're going to do surface area. I'm going to use just A for surface area. Okay, so what's the surface area of a... So, need your help though. Area is equal to what? Surface area. Well, we can do that one. 2 pi RH plus. 2 pi r squared. That's, we got two circles on the, one on the top, one on the bottom. So it's 2 pi r squared. That's the formula for the surface area. Okay. All right, so this is pretty good. This is a pretty good start. If we need to know any more, we'll put it down. Next, what's the next step?